What you need to know about the science of an electric kettle. An electric kettle is a very efficient device for heating water and uses electrical energy to generate heat energy through a metal coil. This heat is transferred to the water, making it boil, while a thermostat turns off the kettle automatically for safety. An electric kettle works using the principle of Joule heating, also known as resistive or ohmic heating. Imagine electricity flowing through a wire where the flow is the movement of tiny particles called electrons. As these electrons move, they collide with the atoms that make up the wire. These collisions cause the atoms to vibrate more rapidly. When atoms vibrate more, their kinetic energy increases, and this generates heat. The more resistance a material offers to the flow of electrons, the more collisions occur, and thus, the more heat is generated. This is why the heating element in an electric kettle is made from a material with high electrical resistance. Here is the step-by-step of how it works. 1. When you plug your electric kettle into a wall socket and switch it on, you complete an electrical circuit. This allows electricity to travel from the socket, through the kettle's cord, into its base. 2. As the electric current flows into the kettle, there is usually a heating element at the bottom of the kettle. This is typically a coil or disc made of special metal alloy like nichrome, an alloy of nickel and chromium of high electrical resistance. As the electric current flows into the kettle, the electrons collide frequently with the atoms of the alloy. These collisions generate a significant amount of heat, making the heating element incredibly hot. 3. The hot element is in direct contact with the water, hence, heat is immediately transferred from the hot element to the water molecules, a process called conduction. As the water at the bottom warms up, it becomes less dense and starts to rise. Meanwhile, cooler, denser water from the top sinks down to take its place, and in turn, gets heated. This continuous circulation of water, driven by temperature differences, is called convection. This process efficiently distributes the heat throughout all the water in the kettle, causing its overall temperature to rise. 4. As the water continues to heat, its temperature eventually reaches its boiling point at 100 degrees Celsius. At this point, the water rapidly changes from a liquid to gas steam, forming bubbles that rise and escape from the kettle spout. 5. Most electric kettles have a thermostat, often a bimetallic strip built in, as a clever safety feature. When the water boils, the steam produced travels up a small channel to reach the thermostat. The heat from the steam causes the bimetallic strip to bend. When it bends far enough, it triggers a switch that breaks the electrical circuit, turning off the kettle. This prevents the kettle from boiling dry and becoming a fire hazard. In summary, an electric kettle takes electricity, converts it into intense heat through resistance, and then efficiently transfers that heat to water until it boils.